One aspect of the FMGS is the assistance provided to the pilot to keep the flight safe and within the flight envelope. This assistance covers the engine failure compensation, the low speed protections, the autopilot flight director mode reversions. Let's look at some of these protections in detail. In case of an engine failure with autopilot on, the FMGC ensures an automatic yaw compensation in all modes. This is achieved by the FAC, using the yaw damper at takeoff and go around, and the automatic rudder trim in all modes. Furthermore, the autopilot flight director speed reference system pitch mode automatically adjusts the reference target guidance speed in case of an engine failure at takeoff or go around. Low speed protection is achieved by the following features: the autothrust speed mode, the low energy warning, the alpha floor protection, and the wind shear protection. When the autothrust is on and in speed mode, if the speed target is selected by the pilot on the FCU and the speed target is below VLS, the autothrust will not allow the speed to decrease below VLS.
Speed, speed, speed.
If, for any reason such as turbulence, shear, autothrust off, the aircraft speed drops significantly below VLS, a repetitive speed, speed, speed oral warning is automatically triggered by the FAC. It drives pilots' eyes to the speed scale, so as to readjust thrust, for example. This warning takes into account the aircraft deceleration rate and current flight path angle, which explains the low energy wording. It is available when the aircraft is on departure and arrival between 100 feet and 2000 feet radio altimeter and in configuration 2, 3 or full. If the aircraft speed continues to drop below the low energy warning and the angle of attack increases above a given threshold, the alpha floor function of the autothrust is triggered. The autothrust commands full thrust, i.e. toga thrust. The angle of attack threshold, which triggers the alpha floor protection, is processed by the FAC as a function of aircraft parameters such as configuration, weight. When alpha floor is triggered, autothrust is turned on if it was previously off, indicated by a white autothrust on the FMA. Alpha floor in green is displayed as the autothrust mode. The alpha floor function is available from liftoff down to 100 feet radio altimeter. Note: the alpha floor protection is lost in cases of combinations of failures such as SFCC1 and FAC2, or both FMGCs, or the alpha floor protection is also lost in case of engine out when slats flaps are extended above configuration 1. When exiting the alpha floor conditions, the autothrust mode reverts to toga lock mode, which indicates that toga thrust is locked regardless of thrust lever position. To regain thrust control, you have to switch off the auto thrust. You now have manual control of the thrust. You may re-engage the auto thrust when convenient.
Wind shear, wind shear, wind shear.
If the aircraft encounters wind shear conditions detected by the FAC, a red wind shear message is triggered on both PFDs, associated with an oral wind shear, wind shear, wind shear warning. This reactive wind shear warning is available from liftoff to 1300 feet at takeoff and from 1300 feet down to 50 feet during landing, with at least Conf 1 selected. The FMGC provides the following protections against wind shear. At takeoff and go-around, with the autopilot flight director speed reference system vertical mode, which commands a pitch, ensuring a minimum positive rate of climb despite a potential speed drop. In approach, with the ground speed mini function, the managed speed target in approach is automatically adjusted with wind variations so as to ensure that the aircraft ground speed does not drop below a minimum value. Note: if the angle of attack gets too high and reaches the fly-by-wire angle of attack protection, the autopilot disengages. The fly-by-wire maximum angle of attack protection assists the pilot to best react. Let's now review the mode reversions of autopilot flight director and auto thrust. The mode reversions are automatic mode changes which allow a comprehensive autoflight system behavior when the pilot modifies a target on the FCU, happen in case of loss of navigation mode, ensure a flight envelope limit speed protection. Let's review the reversion due to FCU altitude changes. Autopilot is on. Suppose we are in climb, using either open climb or climb to flight level 250 as cleared by ATC. While crossing flight level 225, ATC requires us to level off at flight level 220. We therefore select the FCU target altitude to flight level 220. The autopilot flight director vertical mode reverts to vertical speed on the current vertical speed value. Notice also that altitude blue is not armed. It is then up to the pilot to decide how to regain flight level 220. By dialing the desired vertical speed target, i.e. down to -1000 feet, or by pulling the altitude selector to engage open descent. Note: you can imagine the same scenario in descent. Let us see another case. We are now capturing the target altitude, altitude star green. The ATC clears us back up to flight level 250. We therefore select the FCU altitude target to flight level 250. The autopilot flight director vertical mode reverts once again to vertical speed with the current vertical speed value. It is now up to the pilot to decide how to regain altitude target. By pulling the altitude selector to engage open climb, or by dialing the desired vertical speed target, i.e. up to +1500 feet. These are the essential mode reversions linked to FCU target changes which you may have to make in case of ATC late clearances. They ensure no discontinuity in aircraft behavior and leave you full authority to satisfy these clearances. Let's review the reversion mode due to the loss of navigation mode. Suppose we are in climb using climb to flight level 150 as cleared by ATC. While reaching flight level 90, ATC requires us to turn to heading 340. We therefore select the FCU target heading to 340. The autopilot flight director vertical mode reverts from climb to open climb as the lateral mode navigation is replaced by heading. The aircraft pitch behavior is unchanged. Note, if an altitude constraint was targeted with climb mode, it reverts to the FCU selected altitude when open climb mode engages. We have seen the loss of navigation mode in climb. On the right side of the screen, you can review a similar scenario in descent. When heading mode is engaged, which causes the loss of navigation mode, descent mode reverts to vertical speed mode, with the current vertical speed value, and speed mode engages on autothrust. The aircraft pitch behavior is unchanged. Note, the loss of navigation mode may be caused by a flight plan discontinuity. We will now study the mode reversion when the flight director orders are not followed. Manual flight. Suppose the aircraft is manually flown with flight director on, autopilot off. The current vertical mode is open descent and the autothrust mode is thrust idle. In order to demonstrate the next reversion, the aircraft is pitched up, disregarding the flight director orders given by the flight director bars. The speed decreases. When the aircraft reaches VLS minus 2 knots or VLS minus 17 knots with speed brakes extended, the autothrust reverts from thrust idle to speed, and thrust is readjusted to recapture the target speed. Let us see another case. This time we are in climb with thrust climb, open climb modes engaged. For any reason, we do not hand fly the flight director pitch bar, and we pitch the aircraft down. The speed increases. When the aircraft reaches Vmax plus 4 knots, the autothrust reverts to speed mode. Thus, the thrust decreases to recover the target speed. Note, depending on the aircraft configuration, Vmax can be VMO, VLE, or VFE. The flight envelope limit speed protection is ensured by autopilot or autothrust, with flight director on, autopilot off, mode reversion, so that at minimum speed or at maximum speed, the flight director bars are removed. Therefore, the autothrust reverts to speed thrust mode in order to regain target speed. Both FMGCs exchange data through a cross-talk bus and are synchronized. When both FMGCs crosstalk, they are in dual mode of operation. The FMGC which drives the synchronization is called master. The master FMGC is automatically determined by the engagement status of the autopilot flight director. If autopilot 1 is on, FMGC 1 is master. If autopilot 2 is on, FMGC 2 is master. If autopilot 1 plus 2 and/or flight director 1 plus 2 are on, FMGC 1 is master. Here, FMGC 1 is the master as autopilot 1 is on. Thrust is driven by the master FMGC. Note, when flight director 1 plus 2 are on, each FMGC drives its flight director and FMA on its on-side PFD. If the crosstalk is lost between both FMGCs, each FMGC operates independently. This mode of operation is called independent mode. The crew is advised by a message on the scratch pad, independent operation. Notice the amber IND light on each MCDU, which indicates that the on-side FM has detected an independent mode of operation. FMGC drives its own FG, autopilot flight director, its own EFIS, PFD, ND, and its own MCDU. Let us review the failure of one FMGC. FMGC 1, for example. Let's assume we are in flight and no previous faults have occurred. If autopilot 1 and autothrust were engaged, autoflight, autopilot off, and autothrust off are triggered on ECAM. Autopilot 1 and autothrust go off. Note, you can re-engage the autopilot on the healthy side, in our case autopilot 2. If autothrust has disengaged, it can be re-engaged at the same time. Notice the amber FM1 light on the MCDU, which indicates that the on-side FM has failed. MCDU1 is now a copy of the other MCDU with the scratchpad message OPP FMGC in process. This mode of operation is called single mode. Both FMAs display to Flight Director 2, indicating that Flight Director bars on both PFDs are driven by FMGC 2. Additionally, only FMGC 2 position is computed and FMGC 2 tunes the offside nav aids. As a consequence of single mode, ND1 displays set offside RNG mode and map not avail messages as long as ND1 range and mode are not set identically to those of ND2. Here the captain's ND has to be set to the same range as the first officer's ND in order to be able to display navigation map. Set captain's ND range to 80. Let's review a similar failure called FMGC reset, which is a temporary failure of as a consequence of both FMAs display two flight directives. As a consequence of single mode, ND1 displays set offside RNG mode and map not avail messages as long as ND1 range and mode are not set identically to those of ND2. Here the captain's ND has to be set to the same range as the first officer's ND in order to be able to display navigation map. Set captain's ND range to 80. Let's review a similar failure called FMGC reset, which is a temporary failure of one FMGC caused by a software interruption. During the time of the reset, the mode of operation is single mode with slightly different effects. You are in cruise. Autopilot 1 is on. Flight Director 1 plus 2 are on in managed mode. Read the title of the failure. The warning, Autoflight, Autopilot Off, is displayed on the engine warning display. The autopilot has tripped off because its on-side FMS has experienced a reset and a managed mode was engaged. After review and confirmation from the pilot flying, clear autoflight. Observe that the flight director has reverted to heading vertical speed modes and that Autopilot 1 is no longer displayed on the FMA. FMGC 1 is in auto reset. During the time of the reset, the FM mode of operation reverts temporarily from dual to single mode of operation. Since FMGC 1 is in auto reset, Autopilot 2, Flight Director 2 and Autothrust are fully available. Note, depending on the autopilot modes initially engaged and on the type of reset, autopilot loss and flight director reversion may or may not occur. In this example, we are facing one of the most serious cases. During the time of the reset, ND1 displays Map Not Avail red message. Both MCDUs display the aircraft status page with Please Wait on the scratch pad. FM1 light is illuminated on the MCDU. Auto-tuning of nav aids may be lost on side 1. Note, do not use the MCDU while Please Wait message is displayed in order not to increase the reset time. The reset is usually over after a few seconds. All functions are recovered. This is indicated by the disappearance of the Please Wait and Map Not Avail messages, as well as by the extinguishing of the FM1 light. Check your flight plan and the tuned nav aids. Re-engage the Autopilot 1 and Managed Modes. Reselect the most convenient MCDU page. We have studied an FMGC1 reset. We will now review an FCU fault. Suppose the aircraft is in descent. On the engine warning display, read the title of the failure. Note that FCU1 failure has no consequence on the FCU indications, since FCU2 has automatically taken over. The pilot flying will ask you to perform the ECAM actions. Here, only the barometer reference has to be cross-checked between the PFDs, the EFIS control panels and the standby altimeter. Indeed, FCU2 drives both PFD1 and PFD2, including the baro reference. After review and confirmation from the pilot flying, clear autoflight. The status page is displayed for review. No system capability degradation is shown. You can see in the inoperative system column that FCU1 is now inoperative. Clear status. ECAM action completed. We will now review the unlikely double FCU failure. Autopilot 1 and autothrust are on. You are the pilot non-flying. On the ECAM engine warning display, read the title of the failure. The consequences of the FCU1+2 failure are: both autopilots are lost, autothrust is lost and thrust is locked, thrust lock message on FMA. All FCU controls and indications are lost, including the EFIS control panel. On the engine warning display, an additional amber caution comes up. Engine thrust locked is triggered every 5 seconds. The procedure asks to move the thrust levers out of the climb detent so as to recover manual control of the thrust. We will do it for you in order to cancel this ECAM caution. The thrust is now manually adjusted by the pilot flying. Note on the PFD that all targets, speed, heading, altitude are lost and red flags are displayed. Altitude alert is lost. Baro reference changes to standard, whatever the previous setting. Flight path vector is displayed. FMA indications are lost. LS deviation scales are displayed. Mach number indication is lost. On ND, ROSE navigation mode 80 nautical miles range is displayed, regardless of the position of the range selectors on EFIS control panels. Needle 1 VOR ADF is related to VOR 1. Needle 2 VOR ADF is related to ADF 2. Weather radar image is lost. Red weather range message. The pilot flying will ask you to perform the ECAM actions. You will have to deal with the first failure, autopilot off. Clear autoflight. Then you deal with the second failure, autoflight FCU1+2 fault. Check the PFD baro reference, automatically set to standard, with the standby altimeter. Once below the transition level, set the standby altimeter reference to the actual QNH. Once the procedure is achieved and confirmed by the pilot flying, clear autoflight. The status page is displayed for review. As the baro reference is 1013 hectopascals, you have to determine the altitude correction to be applied to get the proper altitude reading, as a function of QNH minus 1013. The approach capability is degraded to Cat 1. You can see in the Inoperative Systems column that both FCUs, both autopilots, and the autothrust are now inoperative. After review and confirmation from the pilot flying, clear status. Completed. We will now review a possible MCDU malfunction. In case you cannot insert any data into the scratch pad, nor change any MCDU page, the MCDU is locked. Such a failure is not automatically detected. To recover the faulty MCDU, simply turn it off and after 5 seconds, back to on. The same procedure would apply in case of an MCDU failure indicated by the amber annunciator fail on the MCDU itself. You can try to recover the faulty MCDU, turn it off and after 5 seconds back to on. If it gives no result, turn it off again.